Right, I still miss you. I still miss you. I'd much rather be in class with you, but this will have to do. Okay. Last time we talked about how to find areas of rectangle, squares, and parallelograms. Now remember, you can use the same formula for all three of those shapes because they're all three technically parallelograms. So you can use base times height. Okay, but remember, in any formula, including the ones we do today, when you look for bases and heights, B's and H's have to be perpendicular to each other. Okay, and then remember, you learned on a triangle that if you put two congruent triangles together, you get a parallelogram. So then naturally the formula for a triangle would be 1/2 base times height because you only want one of the two kind of triangles. So that's kind of where that formula came from. Hopefully the homework was great and you're not confused. If you are, make sure you email me. Okay, what we're going to do today, we're going to do some more formulas, all right, for some more area shapes. Okay, so let's see if we can get a way to share the screen. Okay, there it is. We go. Let's find the correct PowerPoint on a good day. Look at there, life's great. All right, so we're going to do trapezoids, regular polygons, and irregular polygons. We're going to do trapezoids first. Now, kind of preview of coming attractions. Trapezoids also what you get when you put two triangles together, but that's what you get when you put two triangles together that are not congruent. Okay, so look what happens when you get that. All right, remember what a trapezoid is. It's a quadrilateral with a pair of one pair, exactly, not exactly one, but at least one pair of parallel sides. Okay, but remember on a parallelogram, the way that you find the parallel sides, you know, these just kind of look parallel, but I want to make sure on a test, I basically would make sure that I did the notation so you would know that those two sides were parallel. Okay, so if those two sides are parallel, they're the bases. Now notice on the triangles, obviously the base of this top triangle, they label 1 is longer than the base of this second triangle. So they couldn't call them both B. So they called them B1 for base of triangle 1 and B2 for base of triangle 2. Okay, so the bases are different. But notice about the height. From the highest point of this one to the lowest point on triangle 2, and here's your highest point and your lowest point, like here to here. That'd be low all the way up to the highest. They have the same height though, okay? So they did 1/2 base times height on this one and 1/2 base times height on that one, and they just added them. So area of triangle 1 is 1/2 the first base times the height. Now, for notation wise, they just divided by 2 instead of multiplying by 1/2. Okay, same thing. Over here, they do 1/2 base times height, but this base is different than that base. And then they added them. But now notice, remember in algebra when you would factor, they both have the same h and they both have a 1/2, so they pull that out to get the formula. Okay, so this is really the formula that I think probably is best for most people, and that's this. On a trapezoid, your area is 1/2 the sum of the bases. So base 1 plus base 2, then times the height. Okay, so look up here on this one. Now again, let me erase those two things because I need to put them differently. And again, what I would do is I would either tell you that AD is parallel to BC, okay, on a test, or I would draw that notation for parallel that we've been using. You know, you don't have to wonder, it'll be marked. And then again, remember I told you that bases and heights have to be perpendicular. So on your test, I would have that drawn in, that right angle, so you wouldn't be wondering, it looks perpendicular, but you know, is it really perpendicular? Okay, so that's why they have the 6 and the 12 here, because they're the parallel sides. They're looking for that right angle, so that perpendicular is going to be their 4, and there's their 1/2. Now remember order of operations. You do parentheses first. Now it wouldn't matter which one you call B1 and which one you call B2, because 6 plus 12, 12 plus 6, same answer. What property says that? Do you remember? That's right. All right. Community property of addition says that the order that you add two numbers doesn't matter, okay? So that's where they got the 18. Now again, remember what property says the order you multiply doesn't matter. Community property of multiplication, that's right. So it wouldn't matter whether you said half of 18 is 9, which is what they did, and then 9 times 4 is 36. You could do half of 4 is 2, and then 2 times 18 is 36. If you had a calculator, you probably might say 18 times 4 is 72, and then half of 72 is 36. But either way, you get 36, but remember, area square units. So on your homework, make sure you always put your units on there, because if you don't, you'll get nervous on a test and forget them. So it's always square, but that's not said 36 centimeters squared. Remember, that's 36 square centimeters. So make sure that you say it correctly. Now, remember, bases are the parallel sides, and on a trapezoid, the parallel sides don't necessarily have to be top and bottom, okay? So let's go erase those marks, okay? Now here, look, they've got it marked. This side is parallel to that side. So it's not top and bottom, it's parallel sides that are your bases. So again, you'd have to take this 5 4/10 and add it to the 7 6/10. I didn't have enough room, so I had to kind of write it like this. So that's half of base 1 plus base 2. And then remember, you're looking for right angles in there. They are. I drew them in for you. So that's how I know that the 2 3/10 is my height and not the 3 2/10, because there's not a right angle here, so that can't be my height. Height's never going to be slanted. Order of operations, you add first. So when you add 5 4/10 and 7 6/10, you get 13. Okay, and again, you can say 13 times 22 3/10 and then take half of that, and you're going to get 14 and 95 hundredths, and then don't forget your units, square centimeters. So the formula for a trapezoid is super easy, okay? It's very much like the formula for triangle, all right? So you shouldn't have a problem. Now what we're going to do next is find the area of a regular polygon. Now remember, we talked about this in class. Regular doesn't mean like average or normal. A regular polygon has all congruent sides and all congruent angles. So when you don't know a formula, you can always take your shape and divide it into formulas, shapes that have formulas that you know. So that's kind of how we're going to derive the formula for this regular polygon. All right, so look at the one that we're going to start with. All right, look how many sides it's got. 1, 2, 3, 4, 5, 6. All right, do you remember what a six-sided figure is called? All right, that's right, a hexagon. Okay, so this is a hexagon, but it's a regular hexagon. Now again, I would either tell you that, or remember, what I might do is just mark all the sides as congruent. Okay, now they've just put S on all the sides to tell you that they're all the same. Okay, but I'd probably be more likely to mark it like that, or just tell you that it's regular. What's also true is all these angles would be the same. So I'm not going to put this, you don't really, but that angle is going to be the same as that angle. Now think about it. If you had a hexagon, okay, you could find out the sum. Remember, n minus 2 times 180 gives you the sum of the angles on the inside, and then if you divide it by 6, you would know the area of each one of those. Okay. Now, what you're going to do is this. They kind of show you where the formula comes from. They just divided this one into a bunch of triangles. But you know, those triangles are congruent. Now remember, how do you find the area, okay, of a triangle? Well, it's 1/2 base times height, okay? So 1, all right, half, all right, and then you'd have your base, and then you would have your height, okay? Now look at their figure. In their figure, there's their 1/2. Their base is S, so that's why they have S. They just changed the order of that they did it. And their height, they label an A. So this is just 1/2 their base times their height, okay? But remember, that'd be the area of one triangle, but how many do I have? Well, I have 6 triangles, okay? Now, they've talked about this A. It's got a special, it's really the height for that triangle, but if you don't draw the triangles in, like I'll show you in a minute, that's called an apothegm. Now, an apothegm is just the distance from the center to a side, but again, it's got to be perpendicular. And the reason it's got to be perpendicular is to be the height of one of those triangles if you drew it in. And S is just the length of the side. Now, what we did was they kind of changed some order over here. Remember, the order that you multiply doesn't matter. Well, if you did S times N, that'd give you the perimeter. I mean, if all these sides were 5, and you had 6 of them, your perimeter would be 30. Does that make sense? Okay, so they're going to use that to come up with a formula that you kind of need to learn. Okay, so here's your formula. 1/2, all right, apothem AP. Okay, so let me go erase the marks that were on here. All right, and then let me kind of go back and do this. So your formula is going to be 1/2, all right, and apothem. Okay, so we're going to say A for apothem. All right, if I can get it to draw. And then we're going to say P for perimeter. So that's your formula for a regular polygon. So look right here. Do you see that from the middle to the side? And again, on a test, I would draw a right angle there to make sure you understood. So that apothem is 7 inches. So that's where they got the 7. And then they're 8 inches on every side. And I've got 6 sides. So 8 added to itself 6 times would give me my 48. Okay, so if you say 7 times 48, you get 336. And over here to the side, I divided that 336 by 2. Okay, kind of ran out of room. All right, and got 168. Okay, because 2 times that would be that. So let's see if I can go ahead and write it in. So when I do that 16 here, it doesn't want to do. Okay, and I subtract that, you know, that's where you're going to end up getting nothing. So I just kind of ran out of room when I was doing the PowerPoint. But so you get 168, but again, it's going to be square units when you got area. So 1/2 your apothem times your perimeter. Now, if you forgot on a test that formula, but you'll have your notes, you know, you could, like they did, you could go draw in a triangle, a better one than I did, and then you could find the area of that triangle and then multiply it by 6. You'd get exactly the same answer. Okay. All right. So let's go into the next one. Okay. Now on the next one, what we're going to do is talk about irregular. Now, if regular means all congruent sides and angles, you know, if you're irresponsible, you're not responsible, that means they're not congruent. So what you're going to do when you have an irregular figure you don't know a formula for, you're going to divide it into shapes you do know the formula for. So what you could do on this one, for instance, if you wanted to, and the way that you divide it might be different than the way somebody else divides it. Do you see that you could go straight across here if it were straight? It's hard to draw with this little marker. You'd have rectangle 1 and rectangle 2. Well, how do you find the area of a rectangle? Well, do you see that this one would be 6 long and 2 wide? All right, so that would give you 12 square feet. What about this one? Now, this one's not 3 by 5. I need to know how long that length is right there. Now, does it make sense if this top one's a rectangle? If that's 2, then right there, that's going to be 2. Well, if the whole thing is 5 and that one's 2, what would it leave for this length right here? Yeah, you're so smart. Okay, you're right. That's 3. Because when you add 2 to 3, you get your 5. So this thing looks like a rectangle, but it's actually a square. It's 3 feet by 3 feet. So that area is going to be 9. So then to get your total area, you're just going to add the 12 to the 9, and you're going to get 21 square feet. All right, so does that make sense? So if you have a shape that you don't know the formula for, then you just go back and divide it into other things. Now, I want you to notice, I could have divided that way. Now, if I divided that way, 5 times the 3 would give me 15. And again, how long is this length? Well, if this is 3, then the side across from it, if it's a rectangle, is going to also be 3. Well, if the whole thing is 6 and this is 3, do you see that that would leave 3 over here? And again, 3 times 2 is going to be 6. So the scratch work would be different, but when I add those two, I also get 21 square feet. So the way that you divide it might be different than the way that somebody else divides it. Okay, but that's all right. Now let's look at one more. Okay, just to make sure that we're clear. All right, look at this one. Now, this one did the same thing. The way one person divides it up might be different than the way somebody else divides it up. Do you see that this person kind of divided here and then went up here and divided it? So they had a rectangle and a rectangle and a triangle. That's what they saw when they divided it. So how do you find the area of a rectangle? Well, again, it's either length times width, or remember we said you could use base times height. So this is 6 and this is 8, and 6 times 8 gives me 48 square units. All right, do you see that it's 21 all the way across here? But I need to know how tall it is. Well, look, this is 7. Now, if this side's 6, the side across from it is 6. Do you see? So that all the way from there to there would be 7 plus 6, which is 13. So that's why for the middle one, they did the 21 times the 13 and got 273 square units. And then triangles, 1/2 base times height. Okay, so remember that angle right there, when you draw it, make sure it's a right angle. Okay, so if it's 13 over here, and this is a rectangle, it's got to be 13 over there. All right, the same thing, if it's 36 all the way across, if this is 8, that's got to be 8. And if that's 21, that's got to be 21. So from here to here is 29. So if the whole thing's 36, that leaves 7 for that. So they did 1/2 base times height and got that. So how do you get the whole area? Well, you add that rectangle area to that rectangle area to that triangle area. So you get 366 and 5/10 square units. So that's the way like person 1 did it. Well, look at person 2. They just kind of went straight down, and instead of doing 3 shapes, they were able to do 2 shapes because they noticed that that thing's actually a trapezoid. So they just did the rectangle plus the trapezoid. So that rectangle, just like the first one's 48 square units. But let's review trapezoid. Remember, trapezoid, the parallel sides are the bases. Okay, those 2 sides are obviously not parallel. Okay, so those are my bases, the 21 and the 36. So I mean the 21 and the 28. Now where did they get 28? It's 36 all the way across the bottom. See the original figure up here? So if that side is 8 and that side is 8, if you take 8 away from 36, it leaves 28 from here to here. So that's how they got the 28. So remember, you add the bases, parenthesis is first, so that's where they got the 49. That height, remember, you would want that to be perpendicular. All right, so if that over here is 13, then that's going to have to be 13. Okay, so remember that angle is perpendicular. Okay, so, and again, you can say 49 times 13 and then take half of that. Remember, divide it by 2, and you're going to get that many square units. So when you add the 48 for the rectangle to the 318 and 5/10 for the trapezoid, you get the same answer. So on a test, I wouldn't care which way you did it. Okay, now let me show you something else. That's still not the only way to do it. Okay, so let's clear those drawings, because somebody else might come in here and go like this. All right, and then go like that. Do you see what I'm saying? They might end up with a triangle, a rectangle, and a trapezoid. There's just somebody else might not see that. It might end up with like 2 rectangles and 2 triangles. It's just however you divide it in the way that you see it. So when you don't know a formula for something, just divide it into some shapes you do know the formulas for and add all those areas up. Okay, so go try your homework. And again, like usual, if you have any trouble, email me. We can set up a one-on-one Zoom meeting or go back and forth with some pictures. Just let me know if you need some help. Okay, all right. I'm going to stop that and let you go try that homework. All right, I miss you. Bye.